Take 2, here we go. So what I want to begin is Module 10, Lesson 1. This is adding and subtracting polynomials. Just a reminder, you're looking for clues for the word of the week. Once you find the word of the week, email it to me, send it in a private comment or messenger or whatever. You don't want other people to know. First person to tell me does get a prize, and I promise I will make it worthwhile. All right, so let's get started. In order to add and subtract polynomials, there's some definitions that I need you to know to begin with. The first one being monomial. What is a monomial? Oh, I do believe we talked about this earlier in the year, but just to go over it with you again, a monomial consists of one term. So this AX is one term. The 3 all by itself, that's one term. So this is a monomial. This is a monomial. If I was to put them together with a plus sign, it would no longer be a monomial. It would become a binomial, because a binomial is made up of two terms. This is a term, this is a term. Remember, terms are separated by pluses or minuses. So 2x is a term, 3 is a term. I put them together, there's two terms making it a binomial. Just like a bicycle has two wheels, a binomial has two terms. So I'm sure you can guess then that a trinomial has three terms. Once again, terms are separated by pluses or minuses. So this is a term, this is a term, this is a term. When you look at the whole thing, you've got 1, 2, 3 terms making it a trinomial. Then once we get to anything that has 4 or more terms, then we call it a polynomial. So just remember that. 4 or more is referred to as a polynomial. There are 4 terms, 1, 2, 3, 4. They're separated by pluses and minuses. Now, somebody might try to trick you up and say, okay, 2x plus 3x plus 5, how many terms? And you think, oh, separated by pluses or minuses, there's 3 of them, so this is a trinomial. But the key is you always have to simplify first. So I can see right off the bat that those are like terms. 2x plus 3x is 5x. So 5x plus 5 simplifies to 2 terms. So this one is called a binomial. Another thing to remember when we're looking at polynomials is the exponents always have to be positive numbers. See these exponents, they're all understood to be 1. There's a little 1 there, even though it's not written, it's understood. This one has an exponent of 2. Each of these would have an exponent of 1, 1. So all of our exponents on our variables have to be positive numbers in order to identify it. If it has a negative, say let's say I had 2x to the negative 2. Well, we know that that's the same as 2 over x squared. This is no longer a polynomial because this x squared is in the denominator. So we don't want to look at it. We don't even care about it. We just say not a polynomial and move on. So what I would like for you to do is pause the video and identify the following polynomials. So hopefully you paused and you've turned it back on. We're going to identify this. This is one term, so this is called a monomial. The second one, how many terms do I have? 1, 2. 2 terms making it a binomial. This only has one term, just a number. So it's a constant if we're talking about it being a number, but we're not talking about that yet. We'll get there in a minute. So talking about polynomials, how would I identify this? It's a monomial, one term. Okay, looking at this one, we've got 2x to the negative 2 plus 3xy. It's tempting to say binomial, but remember, we cannot have the negative exponent, so we just don't even identify it as a polynomial. Okay, looking at the next one, number 5. Once again, it's really tempting to just look at it and say 1, 2, 3, 4 terms, so this is a polynomial. But if you take a closer look, I can combine these two terms. They're like terms. So really, this is the same as 9x cubed minus 3x minus 27. So if I look at it that way, it's 3 terms, so it's a trinomial. And then number 6 is also a trinomial because it has 1, 2, 3 terms. Remember, I can't combine these. This one's m squared. This is n squared. Those are not like terms. This one has an m and an n, so it's not like the other two. All right, moving on. Degree of a polynomial. When we're talking about polynomials, not only do we name them binomial, trinomial, monomial, polynomial, we look at the degree within each term, and then we say, okay, if it has a 0 degree, it's called a constant. If it has a first degree, we call it linear. If it has a second degree, we call it quadratic. If it has a third degree, it's called a cubic. And then 4 or higher, we just say 4th degree, 5th degree, 6th degree. You may notice in your workbook that they have 4 is called quartic and 5 is called quintic. I've never heard anybody get that specific. They usually always just say 4th degree, 5th degree, or higher once you get beyond there. Okay, so what we have to do, let me explain this, is look at each term. So I'm going to go ahead and put boxes around my terms, and then we're going to look at the degree within each term. So this x is squared, y is cubed, and z has an understood 1 there. We don't look at the degree of the constant or the coefficient, the number. We just look at the degrees on the variables. So if I were to add all those exponents together, 2 plus 3 plus 1, I get 5. So this, as of right now, this is a 5th degree. But we've got to look at each term. This one has a 1, this one has a 2, so this is 3rd, and 1, so this is 2nd. And then we use the greatest degree of any term to name that polynomial. So this is the greatest degree, 5th degree, so we call it a 5th degree. And look at how many terms there are. There's 1, 2, 3 terms. So if you remember, what do we call something with 3 terms? A trinomial. So the 5th degree refers to how many degrees it is, and the name trinomial refers to how many terms there are. So this is a trinomial of the 5th degree. Trinomial of the 5th degree. So let's think about what a constant would look like. It would just be a number by itself. So if I just had 5, that's a constant. -3, that's a constant. Any number, it doesn't have a variable attached to it, so there is no degree on the variable because there is no variable. So it's called a constant. It's just a number. Linear, we've talked about linear all year. 2x plus 4. This is a linear binomial. There are 2 terms. The degree of this term would be 1. The degree of this one is 0 because there is no variable. So we say that this is a linear binomial. Quadratic would be something like 2x squared. Cubic would be something cubed, x to the 3rd power. Something of the 4th degree would be something where the exponents add to 4. And remember, too, with this cubic, it doesn't just have to be x to the 3rd. It could be x squared y. That's still a cubic because 2 and 1 make 3. It could be x, y, z. 1, 2, and 3. That makes a 3rd degree. This term has 3 degrees. So those are different ways that we could look at it. So once again, I would like for you to pause the video and try to name each of the following degrees. These are the same problems as before, just name the degree. So hopefully you paused it. This is a monomial of the 1st degree, but remember we don't say 1st degree, we give it a special name, we say linear. So this is a linear monomial. If we look at this one, 1 and 1 make 2. This has 1, so we would call this a 2nd degree. Well, we don't say second. Instead, we say quadratic. So this is a quadratic binomial. Quadratic binomial. If we look at number 3, it's a constant. There is no variable. It's just a number. So we call this a constant monomial. Number 4, we can't identify it as a polynomial, but we can talk about the degree if we wanted to. We could say it's a 2nd degree, right? Because this has 1 and 1, which makes 2. So we could say it's, well, really we don't even care. We're just not even going to identify it. We're just going to leave that one alone. It is not a polynomial because of the negative exponents, so therefore we don't really worry about it. All right, and then this next one, it has a degree of 3. This has a degree of 1, 1, none. So this would be a cubic trinomial, because remember we combine those. So it's a cubic trinomial. This has a degree of 2. This has a degree of 2. And this has a degree of 2. All of our terms have a degree of 2. So the highest is 2, making it a quadratic. All right, so moving on. I'm going to teach you how to add polynomials. There's a couple different ways that you can do this. I don't care which way works. I'm going to show you a couple different ways, and then you can choose which method works best for you. To me, the easiest thing is to line them up vertically, where I've got 3x squared plus 9x plus 27. I'm adding, so I'm going to add my 2x squared to my 3x. I'm going to add a positive 4x to my 9x, and I'm going to add a negative 12 to 27. So let's just look at this. What is 3x squared plus 2x squared? That's 5x squared. Remember, we only add the coefficients. We do not add the exponents. That's only when we're multiplying. 9 plus 4 is 13, 13x. And 27 plus negative 12, or I could just think of it as 27 minus 12, is a positive 15. So my answer is 5x squared plus 13x plus 15. Now, I'm going to be real honest with you. The shortcut method is what I would technically be using. I would not write all this out. 3x plus 2x, I line it up vertically in my head, I guess, but I don't write it all out. I just look at like terms. 3x plus 2x, and I get 5x squared. Then I go to the next term. 9x and 4x are the same. So 9x plus 4x, I know, is 13x. And then I look at the next term, and I get 27. Take away 12, and that gives me a positive 15. So I get plus 15. Doesn't really matter which way you want to do it. If you want to go ahead and rewrite them all side by side. 3x plus 2x squared plus 9x plus 4x plus 27 plus a negative 12. And then add them all together that way. You'll still get the same thing. 5x squared plus 13x plus 15. All right, I'm going to take a little pause for here just a minute. And our word of the week has... I had to think about this. Has 7 letters. Yes, 7 letters. And the first 3 letters describe a food. Interesting. It's a type of food. It's a meat that a lot of people eat on Easter and sometimes at Christmas. Not usually on Thanksgiving, because usually people have turkey on Thanksgiving. But that's your hint. It is a 7-letter word. The first 3 letters describe a meat, or are a meat. I don't know. It's a word that is a meat. Okay, moving on. Subtracting polynomials. This gets a little bit more complex because this minus is here outside of our parentheses. So we have to distribute, is how most teachers would describe it, distribute that negative throughout. But what that means to me is I'm just going to go through here and change the sign of everything. Negative 7x. Remember, a negative times a negative makes it a positive, so I change that to a positive 3x. If I distribute a negative to the 14, a negative times a positive is a negative. So look what happened. My positive 7 became a negative. My negative 3 became a positive. My positive 14 became a negative. So that's why I just think change the sign of everything and make it a plus, because plus is so much easier than minus for whatever reason. So now we're back to the same problem that we just had, or a similar type problem that we just had before. So I'm just going to vertically align this x underneath of my negative 7x, my 7 underneath of the 14, and I'm going to add them together. So if I have negative 7x and I add 1x, I have negative 6x's now, plus my 3x squared, and a negative 14 and a positive 7 make negative 7. Now, I, as you all know, am totally OCD, And it's not wrong if you were to leave your answer like this, but that is not in what we would call standard form of a polynomial. This is just the order that it was written in, but I like you to write your answer in standard form. Standard form is where the largest exponent comes first. So I'm just rearranging my terms. The commutative property allows me to do that. So I put my 3x squared first. It was positive, stays positive. Then I put my negative 6x. It was negative, so it stays negative. And then I have my negative 7. It's negative, so it stays negative. So this is my answer. And just for funsies, let's give it a name. It is a trinomial. It has 1, 2, 3 terms. And the highest degree, this one has 2, this has 1, this one has none. The negative 7 has none. So we know that it is a second degree trinomial. But do we call it a second degree? No, we call it a quadratic trinomial. All right, that's all that I have for today. Don't forget your word of the week. Don't tell anybody. And I will post some questions tomorrow on a Google document or a Google form. And you will have to answer those and submit those. So please do not share those answers with others. I know Mr. Howard and myself came across some cheating when we were grading. And if it's obvious that you are cheating, I don't care if you work together and help one another, but cheating is a totally different story. I will be giving out zeros. One person doesn't create a Google Doc and share it with everybody else. That's not how we learn. I realize that this is different circumstances and it's a little uncomfortable, but we still have to be doing the work. We still have to learn. I'm trying my best. Mr. Howard's working really hard. We need you guys to do your part and at least try. I'm giving you points for trying. Try. Do not cheat. Stay safe, and I will talk